Common operations on linked lists include some things we've already done, such as adding to the end of a linked list, traversing a linked list, but also some other things such as inserting an element somewhere in a linked list or deleting an element from a linked list. Whatever it is you're doing, it's always important to maintain the integrity of the linked list and to write general code. So it will check for special cases such as when you're working with the first or the last element in the linked list. So for example, if you have a linked list and you're deleting the first element, then you're going to have to change first. Another thing to check for is to see whether you actually have a linked list. So check the value first. If it's null, then you don't even have a linked list to begin with. So let's say that we want to delete the first element in the linked list. We could say first gets a value first arrow next, so move first to point over here. But if we did that, then we wouldn't have any way of deallocating or freeing up this space. So if we wanted to do that, then we could have another pointer, for example, current. And one thing we can do is set it equal to first, and then say first is first arrow next. So instead of pointing here, first is going to point over to the next element. And then we can free up the space that current is pointing to. So now first is pointing over here. We've deleted this first element, including freeing up the space, and first is pointing over to the next element in the linked list, which is now the first element in the linked list. So it's important to make the code general. We should actually check to see whether there is a linked list to begin with, so check the value first to see whether it's null or not. And also check to see whether there's only one element. So if there's only one element in the linked list, then it's both the first element and the last element, and so we would have to change both first and last to be null, because if we're deleting the first element, we're basically deleting the entire linked list, so both first and last would be null. So here's general code to delete the first element. First of all, we're going to check to see whether we have a linked list. So if first is not equal to null, then we'll execute this action. So in other words, we're going to do nothing if we don't have a linked list to begin with. So if first is null, we don't have a linked list, so there's nothing to do. So if we do have a linked list, the first thing we'll check to see is whether there's only one element. So if first is equal to last, then there's only one element in the linked list, so I want to free up that space and then set both first and last equal to null because we don't have a linked list anymore. We just got rid of it. Else, so if there's more than one element, then we can use our general code in which we're going to set current to first, move first over to the next element in the linked list, and then free that space. So in this case, in this code, we're checking for all the special cases. All right, let's take a look at another example. Let's say we have a linked list, and we have a current pointer pointing somewhere in the linked list. And what we want to do is to insert another element in the linked list after the current one. So in other words, in between these two elements, I want to dynamically allocate a new location and hook this up to the linked list so that this becomes after the current element. Well, this current arrow next pointer, I can't just say that gets the value of a new location, because if I did that, then I've lost the rest of the linked list. I don't have any way of referring to this element in the linked list. So what I need to do first is I need to have some kind of temporary pointer, and I need to point it to the rest of the linked list, which means current arrow next. I want it to point to that next element. Then, after I have the temporary pointer in place, I can say current arrow next gets the value of this new location. And then this pointer, which is current arrow next, is going to be equal to temp. So now I've got a new location. I've hooked it up to the linked list. So I've maintained the integrity of the linked list.